In this video, we're going to go ahead and take a look at graphing images of rotations. So again, a rotation here, we talk through rotations. A rotation is going to be a transformation in which an object is turned or pivots. The fixed point about what we pivot is called the center of rotation, and we can draw rays from it to create an angle of rotation. So you have a rotation here. Like I said, it's a transformation in which the object is turned or pivots around a fixed point. It's also important to note the direction counterclockwise versus clockwise. So noting those directions here. If we don't imply a direction, we're going to assume it would be counterclockwise. All right, so graphing the image of a rotation. So let's start here. Rotate the point by the given angle, and we're going to go counterclockwise here. So I'm going to take a point 4, 2. And we're going to rotate this coordinate 90 degrees. So what's really going to happen here is imagine if I draw from the origin to this point, and we want to rotate that point 90 degrees, and we're going to go 90 degrees counterclockwise. It's standard practice that if you think about a coordinate plane here, it starts in quadrant 1, goes to quadrant 2, goes to quadrant 3, goes to quadrant 4, and we keep going in this counterclockwise rotation here. So we're going to keep that same manner here with a counterclockwise rotation. So if you wanted to think about this with just for example, we throw a protractor here. And we draw 90 degrees. We draw our 90 degrees right here. Then I know that this should fall along this 90 degree right here as well. So then I can hide this protractor. So I know that that's going to be a 90 degree rotation. I also know previously from the concept of slope that 90 degrees implies that it's perpendicular. And perpendicular means the slope should be an opposite reciprocal. So for example, if we look at point P here, we have this up 2 over 4. So the slope for that point is 2/4. And if I want perpendicular slope, that's going to be -4 over 2. We switch them and change the sign. So if you imagine the point right here, where we would go down 4 and over 2, that can give us P prime. So now that's a lot of work if we're going to do this for multiple points, but if we can start seeing the relationship here, that the point P can go from 4, 2 to P prime being -2, 4, then what really happens is the same concept with rotation or with a perpendicular slope, where we switch your x and your y, and that's where this comes from, the word reciprocal. You switch the x and the y, you exchange your numerator and the denominator, and then you need to change the sign of your new x value, and that's where this word opposite comes into play. So we need to change one of the signs here. Now if we do the same thing 90 degrees, let's do it one more time. We can start seeing this relationship. So negative 3, 1. And you'll notice here that we have negative 3, 1. So note my slope here is 1 over negative 3. I need to flip this slope and change the sign. So I need to go 3 and 1. Now, if you think about going 3 and 1, I'm actually going right here where I can go up 3 and over 1. And there's this new point for P prime here. So my 90-degree rotation is taking this point from P, it's rotating it down to this point for P prime. And it's rotating it 90 degrees again counterclockwise. We can also look at this as the point P goes to from negative 3, 1. We switch the values to get P prime, 1, negative 3. And we change the sign of the new x. So it becomes negative 1, negative 3. All right, so as we keep going here, we're going to rotate now 180 degrees. And one way that you can think about 180 is really it's like doing 90 twice. It's like doing 90 twice. So if I take 6, negative 2, okay, now imagine we got the 6, negative 2 here, so I'm going to just draw this out. Here's plus 6, negative 2. So if I do a 90-degree rotation, that's going to switch these. And it needs to change the sign. So we end up having 6, 2, putting this new point here at a delta x of 2 and a delta y of 6. So here's my 90-degree rotation for P prime. And then we do it again. So we can switch these coordinates, and we change the sign. So you end up getting 2 and negative 6, which means we're going to end up going a height of 2 and a negative 6, and that gives us our point P prime. Or P double in this case, because I did it twice. And that's what a 180-degree rotation is really composed of, is two 90-degree rotations here. Okay, so if we take a look at this, note that these points end up having a relationship where they're linear. 180 degrees is linear. And we have this positive 6 here becoming a negative 6 here. We have this negative 2 becoming a positive 2. And so what's really happening is our point changes from P of 6, negative 2 all the way to P prime of negative 2, 6. And so really what's happening here, 6, negative 2 to negative 6, positive 2. So what's really happening here is we are just changing the signs of our x and our y values. So we're changing the signs of both the x and the y values here. So if we do 180 one more time, we can see that the 180 should just change the signs of both of these values. So -2, -6 should go to 2, 6. So here's our -2, -6. And here's our 2, 6. That's a 180-degree rotation here. 180-degree rotation. And again, if you think about these rays drawn out, you can see how this would be linear, creating this 180-degree rotation. All right, let's do a 270 degrees. Now, the way I look at 270 could be twofold. Either you can look at it doing 93 times. So if we do a 90-degree rotation, that should change the x and the y and change the sign of the first one. So for example, if I start with -2, 3, that should take me to -3, -2. There's my 90-degree rotation here. We do it again. Switch the x and the y and change the sign of the first one. There's another 90-degree rotation. Or from here to here is a 180-degree rotation. And we'll do it one more time. So we'll switch the signs. Or we'll switch the x and the y, and then we'll change the sign of the first one, becoming 3, 2. And together that makes up a 270-degree rotation. You can also look at this by doing a 90-degree clockwise. Now, if you look at the start to the end, we went from -2, 3 to 3, 2. Which means what really happened was we switched our x and our y, and that's where that word reciprocal again comes from, and we changed the sign of our new y. So that leads us into these coordinate rules here for a reflection, or for a rotation. When you have a point AB rotated counterclockwise about the origin, what ends up happening is a 90-degree rotation, switches your x and the y, so this switches the x and the y, and it changes the sign of your new x. The 270 does the same thing. It switches switches your x and your y, and it changes the sign of your new y value. And if you think about this, if you go from a 90 to 180, you're really switching twice. So if you switch them and switch them back, it gets back to where it was. So what ends up happening here is you're really just going to change both signs, because switching twice gets us back to where we were. So you're changing both signs. All right, so we're going to jump into IXL here, and we'll take a look at some objectives involving rotations here. All right, I'm going to go ahead and write these rules down. These are for counterclockwise rotations. is going to take a point AB, and it's going to, for a 90, send that point to negative BA, which means to switch your x and your y and change the sign of the new x. 180 will change the sign of both of these, and a 270 will switch them and change the sign of the new y. So I would recommend looking at this and thinking about a 270-degree rotation. Think about the coordinates here. So we have u at -3, -6. We have t at -3, -7. We have s at -6, -7. And we have v at -6, -6. So for 270, we need to switch your x and y and change the sign of our new y. So we're going to switch these. And then we change the sign of the new y. So I'm going to go ahead and graph those coordinates, -6, 3. -7, 3, -7, 6, and -6, 6. Here we're going to graph a 180-degree rotation. In the same manner, I'm going to write these coordinates down. So D is at -2, 10. C is at -9, 10. E is at -7, 2. For 180, we are going to change the signs of both our x and our y. So this becomes +2, -10, +9, -10, +7, -2. And I'm going to go ahead and graph those out. So +2, -10. +9, -10, and +7, -2. All right, and then we have a 90-degree rotation here. So again, I'm going to write the coordinates for C is at -3, -6. Then we have B at -3, -10. A is at -7, -10. And D is at -7, -6. Your 90-degree counterclockwise rotation is going to change or switch our x and our y, and it's going to change the sign of our new x. So we're going to switch these. And change the sign of the new x. So positive, 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 positive. And then we're going to graph that out. So 6, -3, 10, -3, 10, -7, and 6, -7.